Hello and welcome. In this video, we're going to discuss series resistors. Resistors have two terminals, and they have a polarity that is linear, which means that it does not matter what direction you place them into the circuit, you can orient them either direction, and they will still be the same resistance. The total resistance is going to be the sum of each of the resistors in series. And we know that this one is in series because from point A, we can look up and follow the pathway, and we have no choice but to go through each one of these resistors. There's not a secondary path for us to go around any of this resistance. And it leads us all the way back to point B here. And this is implying that we're going to place a battery source right here. And that's going to be the circuit's perspective, which it means that the current is going to travel up and around through R1, down through R2, R3, across R4, and then up to B here at our negative terminal from our positive. So we are going to solve for the total series resistance in this circuit. And again, the total resistance, RT, is equal to the sum of each of our resistors. And we have four resistors in this circuit, so we can say that our RT is equal to, and we can add them all up. We can say it's R1 plus R2 plus R3 plus R4, but watch out for the notation, because R2, R3, and R4 are all in mega ohms, and R1 is in kilo ohms. So we have to adjust that. We have to make sure that all of them match or that we account for those zeros. And so the easiest way to do this is just to convert R1 into mega ohms. So we know that from right here is our decimal point, and this K tells us that we're at the positive 3 location. And so we can move forward. We know that this M over here tells us that that's the positive 6 location. And so we want to move this one into our positive 6 location. So we'll move it forward 1, 2, 3, and bring it up to the 6 and put our decimal point there. So this resistor we're going to represent as a 0.723 mega ohms. Right now they're all in mega ohms, and we can use that in our calculations. So we'll solve out our RT using our Desmos here. We'll plug those in directly now that we've converted them all into now that we've converted them all into mega ohms. We can say 0.723 plus 24.6 plus 35.4 plus 11.3. And that gives us 72. We can round that off. Remember, resistors have tolerance, and so they're often going to be rounded more. And then this one is going to stay in mega ohms, right? Because everything else was in mega ohms. Even though we didn't account for it in our actual calculation here, we know that the answers were all going to be in mega ohms because all of the resistors were in mega ohms, right? Let us know if you have any questions.